Unit 7. Flood Waste. The floodway concept and purpose. The floodway is one of the most important and restrictive regulatory tools in floodplain management. It represents the channel of a river or stream, plus the adjacent land areas that must be reserved to discharge the base flood without cumulatively increasing the water surface elevation more than 1 foot at any point along the watercourse. Understanding the floodway requires understanding the physics of flood flow. During floods, water moves through river channels and spreads across adjacent floodplains. The channel typically carries the highest velocity water, while the floodplain areas carry slower moving water. However, all of this area contributes to the conveyance of floodwater. If development is allowed to encroach into the floodplain, it reduces the area available for floodwater flow. This causes floodwater to rise higher to pass the same amount of water through a smaller area. The higher water levels affect not only the area of the encroachment, but also areas upstream, potentially affecting properties that were previously safe from flooding. The floodway concept prevents this problem by prohibiting encroachments that would cause any increase in upstream flood levels. The no-rise standard is absolute. No increase in flood levels is acceptable, no matter how small. Floodways are determined through hydraulic engineering analysis using computer models that simulate flood flow patterns. The analysis starts by modeling existing conditions to establish baseline flood levels. Then the model tests different floodway boundaries to find the area needed to convey the base flood without causing more than 1 foot of rise. The 1 foot rise criterion is a balance between flood conveyance needs and development pressures. A no-rise standard would be safer, but would be so restrictive that little development would be possible. The 1 foot criterion allows some development while providing reasonable flood protection, floodway boundaries and mapping. Floodway boundaries are shown on flood insurance rate maps as dashed lines within Zone AE areas. The floodway includes the channel, plus portions of the adjacent floodplain, typically extending different distances on each side of the channel, depending on topography and development patterns. Reading floodway boundaries on maps requires careful attention to detail. The floodway boundary may follow property lines, roads, or other features, but it is ultimately determined by hydraulic analysis. Property owners need to determine exactly where the floodway boundary crosses their property, which may require professional surveying. Floodway boundaries can change over time as physical conditions change or as more detailed analyses are performed. Major development projects, channel modifications, or improved mapping techniques can all result in floodway boundary changes. When floodway boundaries change, it affects the regulatory requirements for affected properties. Properties that are newly included in the floodway become subject to more restrictive development standards, while properties removed from the floodway have fewer restrictions. Cross-sections shown on FIRMs indicate where detailed hydraulic analyses were performed to determine floodway boundaries. These cross-sections are tied to detailed hydraulic profiles in the flood insurance study that show water surface elevations and floodway limits. Development restrictions in floodways. Development restrictions in floodways are the most stringent in floodplain management. The basic rule is that no encroachment is allowed that would result in any increase in flood levels during base flood conditions. This creates a very high bar for any development in floodway areas. Fill is generally prohibited in floodways unless it can be demonstrated that it will not cause any rise in base flood elevations. This is extremely difficult to achieve except in limited circumstances, such as when compensatory excavation is provided to offset the effects of the fill. Structures are generally prohibited in floodways unless it can be demonstrated that they will not cause any rise in flood levels. Most structures will cause some rise, making development in floodway areas very limited. The few structures that might be allowed include certain types of bridges, utilities, and structures specifically designed to minimize flow obstruction. Storage of materials and equipment is typically prohibited in floodways because these items can become debris during floods and can obstruct flood flows. Temporary storage might be allowed if materials are removed before floods occur, but this requires reliable flood warning systems and emergency procedures, Agricultural uses are often allowed in floodways because farming practices typically do not involve permanent structures or significant flow obstructions. However, even agricultural activities must be reviewed to ensure they do not cause flow obstructions or increase erosion problems. Recreational uses like parks and trails are often appropriate in floodways because they do not involve significant flow obstructions. However, any associated structures, like pavilions or restrooms, must meet the no-rise requirement. Encroachment analysis requirements. Any development proposed in a floodway must be supported by an encroachment analysis that demonstrates no rise in base flood elevations. This analysis must be performed by a qualified engineer using accepted hydraulic engineering methods and must meet FEMA's standards for technical accuracy. The encroachment analysis must use the same hydraulic model and methods used to determine the existing floodway boundaries. This ensures consistency and accuracy in the analysis. The engineer must have access to the original hydraulic model or must develop a new model that replicates the existing conditions shown on the effective FIRM. The analysis must model both existing conditions and post-development conditions to determine the change in water surface elevations. The comparison must show that no increase occurs at any point along the watercourse, not just at the location of the proposed development. Compensatory storage is sometimes used to offset the effects of proposed encroachments. This involves excavating areas adjacent to the proposed fill to provide additional flood storage that compensates for the lost storage caused by the fill. The compensatory storage must be hydraulically connected to the floodway and must provide equivalent volume below corresponding elevations. The technical analysis must be certified by a registered professional engineer with experience in hydraulic engineering. The engineer must certify that the analysis meets FEMA standards and that the proposed development will not cause any increase in base flood elevations. Conditional letters of map revision. For significant floodway encroachments, developers often seek conditional letters of map revision, CLOMRs, from FEMA before beginning construction. A CLOMR provides preliminary approval for a project that will affect floodway boundaries or base flood elevations. The CLOMR process involves submitting detailed technical information to FEMA for review, including hydraulic analyses, topographic surveys, and construction plans. FEMA's review confirms that the project, if built as proposed, will result in a letter of map revision, LOMR, after construction is complete. Obtaining a CLOMR provides assurance to developers and lenders that the project will be approved by FEMA and will result in map changes that reflect the post-construction flood conditions. This is particularly important for large developments that depend on map changes for their feasibility. The CLOMR process can take several months and requires detailed technical documentation. The submittals must meet FEMA's standards for accuracy and completeness and must be prepared by qualified professionals. After construction is complete and consistent with the approved CLOMR, the developer can submit a LOMR request with as-built documentation to obtain the final map revision. This process typically moves more quickly than the initial CLOMR, because the technical analysis has already been approved. Common floodway violations. Floodway violations are among the most serious floodplain management violations because they can affect flood levels over large areas and can impact many upstream properties. Common violations include unauthorized placement of fill, construction of structures without proper analysis, and storage of materials or equipment. Unauthorized fill in floodways is probably the most common violation. Property owners may place fill for building pads, driveways, or other purposes without realizing they are in the floodway or without understanding the restrictions. Even small amounts of fill can cause significant rises in flood levels. Structures built in floodways without proper hydraulic analysis create serious violations. These might include buildings, sheds, fences, or other structures that obstruct flood flows. The impact depends on the size and location of the structure and the characteristics of the floodway. Storage violations in floodways can involve construction materials, equipment, vehicles, or other items that could obstruct flows or become debris during floods. These violations are often temporary, but can still cause significant problems if they occur during flood events. Landscaping and grading in floodways can create violations if they alter flow patterns or create flow obstructions. This might include berms, terracing, or other modifications that were not analysed for hydraulic impacts. Agricultural activities in floodways can sometimes create violations, particularly when they involve construction of berms, drainage modifications, or installation of equipment that could obstruct flows.